Hey everyone, I am Evan Vishy. I am the community manager at Tatum, and I'm here with Sam Sramko. He's our CTO, the brains behind the operation. And we're going to be showing you how to get started in Tatum. So what is Tatum? Tatum is a blockchain development platform. We provide infrastructure and SDKs and an API for over 40 blockchain protocols. You don't need any blockchain experience to build apps on them. You can use our platform to build apps on any of them with no previous blockchain experience. So what we're going to do today is help you get onboarded pretty quickly, get started in the platform. The first thing you're going to want to do to get started in Tatum is to get an API key. So Sam is going to sign us up here into our dashboard. Yeah, so you need to go to dashboard.tatum.io. We will have a link in the description for you. Great. And we're going to sign up for a free API key. So you can do everything with a free API key. The only difference is that you're limited to 5 API calls per second. So if you need any more than that, meaning when your app starts to get some traffic from users, you can upgrade to a paid plan. Exact same features, but you then have 200 API calls per second. And that's just for $9 a month. So it's about the cost of a Netflix subscription, and it's a lot of power to run any sort of enterprise grade app. So let's sign up for this free one. We just select testnet in this case, or mainnet, name the key. So we've created our API key. Then we're going to copy it. So we click show, copy the API key. This is the key we're going to be using in all of the API calls we'll be showing you. This is how you communicate with Tatum's infrastructure. So now we're going to be communicating directly with Tatum's API. And we're going to show you how to generate a wallet, generate a deposit address, and generate a private key. And then we'll be showing you how to create an NFT, deploy the contract, and mint an NFT, and then transfer that NFT. So first off, let's start with generating a wallet on Polygon.
Yeah, thank you, Evan. So hi, guys. First of all, there is a couple of useful links in the dashboard. And the first one is our developer zone, where you can see a lot of guides. Plus, there is API reference to the APIs we are going to use today. So today we are going to, as Evan said, use the Polygon stuff. We will generate wallet, generate addresses, private keys, and work with the NFTs. In the platform, there is much more than that, not just NFT. You can work with any blockchain. You can work with Bitcoin and others, but the NFT are the most simple one. So let's start directly with integrating to the platform. Today, I will use the Postman tool. It's a nice tool for working with APIs. And I have prepared a couple of endpoints for you right now. All of them will be also available in the API reference. So first of all, if you want to work with any blockchain, you need the wallet, and you need address, and you need private key for the blockchain you want to work with. So first step for anyone is to generate the wallet. The URL is the URL of the API we are communicating with. It's API EU1 Tatum IO, and the API key we have copied should be passed as a XAPI HTTP header with the value of the API key. For the wallet, it's pretty simple. We just use a get operation, and let's generate the wallet. The result of the operation is mnemonic and extended public key. The mnemonic is the most secure stuff you can have in the blockchain space. It can generate every private key which is available from this wallet, and one wallet can hold more than 2 billion of the private keys and addresses. So once you lose your mnemonic, you will use access to all your data in each of the address you have created from that wallet. Extended public key, or XPUB, is the read-only generator of addresses. So we can imagine XPUB as a generator of addresses and a mnemonic as a generator of private keys. And both of these informations are important for you. So we have created the wallet, And right now we want to create a private key from that wallet. So as I said, the mnemonic is the way of creating private keys and working with the sensitive information. So in the API call, generate private key from the wallet, we need to enter the mnemonic we have obtained from the first call, plus the index of the wallet or of the specific address and the private key we will work with. The first address from the mnemonic start with index 0. You can have, as I said, more than 2 billions of the addresses. So let's generate the wallet, the private key from the wallet number 0, or the first one. The result is the key, which is again the sensitive information. And with this private key, you will access, you will sign most of the blockchain transactions, like creating NFTs, transferring, etc., etc. Everything is hidden in the private key. But as you already know, if you want to work with, if you want to receive some assets or send some, or receive some assets to this private key, you need an address, which is a public read-only information shareable with everyone else on the blockchain. And to access this address or to generate address number 0, which is connected to this private key we have created, we have another endpoint, and it's a generate address from extended public key. So the step here is to obtain the public key, obtain the extended public key from the generate wallet operation, pass it as a parameter, and we want to obtain address 0. And we have the address. This address corresponds to this private key we have created in the previous call. Index 0 must match index 0, and xpub must match the mnemonic from the generate wallet operation. But right now, in 3 API calls, we have created address, we have created private key, and we have generated the wallet. So that's pretty simple. And what's even more fun is that you can work the same way with any other blockchain we are running. And it could be Binance Smart Chain, it could be Ethereum, it could be Bitcoin, Litecoin, etc., etc., and many more of them. So the same approaches applies to all other chains we have.
So great. So now that we have generated a Polygon wallet to create private keys and Polygon addresses, and we have also created a Polygon address from an extended public key and generated a Polygon private key, now we can receive assets to the private address or to the address, and we can use the private key to transfer these funds from the address. So what we're going to do now is we're going to move into creating an NFT smart contract and then minting an NFT and transferring it to the address we have created. Usually when you deploy an NFT smart contract, you would have to build this from scratch using Solidity in the case of Polygon. But with us, we already have these smart contracts already to go for you. So we are going to generate a smart contract in one API call, and then we're going to mint an NFT, and then we're going to send it. So show them how it's done, Sam.
Sure, thanks, Evan. So I have prepared again a couple of API calls. We will work with the NFT section and the NFT endpoints. First of all, we need to have some testnet assets available on the blockchain address we want to deploy the smart contract from. So we have generated address, we have generated a private key for that address. So we need to receive some matic on this address. For that, we can leverage the testnet faucet the matic guys provide, and we will receive the testnet assets from them. On the faucet, we need to choose the Mumbai network. We want to receive the matic token, and we paste here the address we have created. So let's ask for 0.1 matic. I'm afraid 0.1 matic is not enough for deploying the contract, but we can try that, and we will see if it will work or not. we can see that we have received 0.1 Matic to our blockchain address. Let's try to deploy the NFT. Deploying NFT, it's super simple. It just requires 4 parameters for you. It's going to be the name of the NFT token, the symbol, the chain you want to work with, and the private key. So let's use the private key from our generate private key call. We want to work on a Matic chain, and let's do the test. Let's do the test token. Let's do that. And the 0.1 should be just enough. The result of the deploying the contract is the transaction ID. The transaction ID could be found on the block explorer, and we can see on the block explorer that the result of the operation is a smart contract address. So we have created a smart contract on the blockchain, and everything we will want to do with the NFTs, we need to invoke operations on this smart contract. So if we want to create new NFT or transfer the NFT or burn the NFT or read the information about the NFT, we need to communicate with this 0x896, etc. smart contract. So we need to copy this address. And the private key you were using is the private key which was used for deploying. And right now, only this private key has power to create new NFT tokens. So only from this one account right now, it's possible to create or mint new NFT tokens. So let's mint a new one. The mint is a little bit more difficult. It doesn't have 4 parameters, but 6. And what's necessary here is, again, first most important part is the contract address. This is the address of the NFT contract we have deployed in the previous step. We want to work on the Matic chain. We need to use the private key we have used for deployment. And the last 3 operations are customizable right now. We need to define the recipient of the token. So who will receive the newly created NFT? We need to define ID of the token, which should be unique across other tokens for this specific smart contract. So let's start with token number 1. And we need to define the URL of the JSON metadata scheme of the data connected to this NFT. This is like the most, let's say, complicated part, because this URL should point to the JSON file which describes the content of the NFT. And the NFT content is usually image or video or audio, name and description. Right now I have some dummy data there, but this should point to the IPFS location or S3 location or your private server location where you will describe the content of the NFT. Let's just use the dummy URL here. It's not important right now. And let's just hit send and let's mint new NFT. The result again is a transaction ID. This transaction ID could be located on the blockchain explorer, and we can see that we have created new token number 1 of the test smart contract, and we have sent it to the recipient 80D8, etc., exactly as we defined in the API call. So right now we have created our new NFT token number 1, and someone has that. The final operation I'm going to show today is transferring this NFT token from this address to someone else. So let's transfer it to our address we have created, to the original one. Again, what's important is to know the contract address. We want to work on a Matic chain. We want to transfer token number 1. And the recipient should be our address. We want to transfer it to our address. And the private key right now should be the private key of the owner of the token. So right now it should be private key connected to the address 80D, etc., etc. It's this one. So let's just transfer it. Again, the result is the transaction ID, which can be found on the Explorer. And we can see that we have transferred token from 80 to XD56 to ourselves. And that's how it is. That's how it works. You need 3 API calls. You need to deploy the NFT contract. And then on that NFT contract, you can mint as many tokens as you wish. And you can transfer the tokens to the specified recipients of your choice.
Perfect. And I wanted to ask about the storing of the metadata. How can they do that using Tatum?
Yes. How they can do that using Tatum? We have the IPFS endpoints available for storing of the data. The problem with the IPFS in general, or with the decentralized storage, is that you need to pay for the storage forever. Someone has to pay for the data which is stored on the IPFS or on the Filecoin or everywhere else. So if you want to store this data for the NFT, you need to pay for your customers if you are the owner of the NFT, or your customers in the future, or the new holders or owners of the NFT should pay for storing the data.
Sure.
Right now, we have partnered up with Protocol Labs, and we give you developers lifetime unlimited free IPFS storage for your NFT data. So anyone can upload anything to the IPFS which is related to the NFTs, and you can store the data there forever, and you don't have to pay, or your customers or the owners of the NFTs don't have to pay. Now I want to upload the image to the IPFS, so let's choose the file you want to upload. This file will be, first of all, the image or the audio or the video or whatever you want to upload, and you hit send. And what we receive the identifier on the IPFS network of our file we have uploaded. The same applies to the metadata JSON scheme you want to upload. So you can upload just the metadata which describes the content of the NFT. Right now, I'm going to show you how the NFT metadata scheme should look like. So you want to describe the NFT with a name. You want to use some kind of description to that NFT. My super nice NFT. And what's important, you want to put the image there. We have uploaded the image before to the IPFS. So we will use that IPFS identifier. We can prefix it with the IPFS. And that's it. This is the metadata we need to upload and we need to store with the NFT. So let's save it as a metadata.json. And right now, when we use the IPFS endpoint one more time, we will upload the metadata JSON there. This URL should right now point to our metadata JSON. So we have the metadata right now available. We have updated to the IPFS. And now in the mint operation, we can put this IPFS URL to the mint of the token. So right now, the token will be connected to this IPFS metadata and described.
So, and I just wanted to ask, if they weren't using Tatum, what would people have to do? What are all the steps involved?
Yeah. If you don't want to use Tatum, or if you can't for any reason, you need to create the smart contract by yourself. If we take a look to the smart contract, how to work with the Solidity, you need to go over the whole tutorial, learn how to write the code. Then you need to write the specific smart contract for ERC-721. You need to compile it, you need to deploy it, you need to, again, run your own Ethereum node or connect to any provider, which gives you the power to connect, which on the other hand, we do as well. We also have the Web3 endpoint, and you can connect to the native API calls of the node. And then you need to deploy the contract, test it, integrate to the smart contract via the Web3, all the methods, all the data, process, etc., etc. Nothing is prepared. You need to do it by yourself.
Wow. So yeah, I mean, that sounds like quite a bit of work. But again, if you want to do it yourself and create your own smart contracts and deploy them using Tatum directly for the nodes, you can using our Web3 HTTP driver. So, and if you don't, you can use our pre-made smart contracts. And we also have ERC 1155 contracts and fungible tokens, ERC 20 token smart contracts ready to rumble. So, well, that's it. So I hope this gives you a better idea of how to get started with Tatum. Now you should know how to get an API key, how to generate a wallet, private key, and deposit address, how to deploy a smart contract, how to mint a new NFT, how to transfer the NFT, and how to work with metadata using our API. So thanks a lot for joining us. And if you have any questions, please join our Telegram channel, or you can post on the Tatum subreddit. And we've got a huge community of developers who are really quick to help. And also our tech team is very responsive. So those links will be below in the description. And I hope you have a good time getting started with Tatum. Happy coding.